All right, so number 14 is, I think, one of the most challenging questions on this whole sample exam. 14 gives us this diagram of a running track, and we actually answered A and B previously in class on that last geometry worksheet. So Kayla running on the inside of the track, we're asking for a perimeter of this. Oops, that's a terrible drawing. But if we're looking for that perimeter, well, then we have four different pieces, right? We have this straight line, which is also the same. They've told us that these are both 100. And we have the two curved portions. Notice if we put the two curved portions back together, we have a whole circle. And if we're talking about going around the circle, the perimeter of a circle, that's when we're looking for circumference. And remember, this is the circumference of a whole circle just because we happen to have the two halves. So circumference is 2 pi r. So in this case, 2 pi, and if this is 64, half of it is 32. That's our radius around that circle. So 2 pi times 32 is going to be our circumference. 2 pi times 32, 64 pi, and if we press the squiggle button on our calculators, it'll tell me that this is 201.06. And if you've ever run a track, you know one time around is a 400 meter. So we feel real good about a 401.06 meter measurement. Now then they also say, okay, well, what about Emmy? Emmy runs along the outer edge. So she's doing this instead. So the thing is, for Emmy, the straight part is exactly the same. She's still going to have 100 plus 100. What's going to change for Emmy is that the exterior, right, this portion is a wider circle. And that's where we have to use the fact that the track is 10 meters wide. So we're going to have the 32 from the original plus an extra 10 meters. So that means the overall radius from here to here for Emmy is going to be 42. So we're going to do the same circumference formula, except for now, 2 pi is going to be times 42 instead of 32, right? So 2 times pi times 42, squiggles, 263.89. So now we're looking at 463.89. Definitely don't want to go around the outside of the track. This is why when those runners have different starts, they're staggered so that they don't all kind of run the same. They all run the same distance when there's a race. All right, so C and D are the new, very challenging pieces. C says if the interior of the track is going to be filled with grass, how many square feet of grass should they order? Oh God. This should say square meters because I did not give you a conversion. That is a typo. Maybe I did. No, because it would have at least been yards. So yeah, no. This should just say square meters. I'm not trying to make this an evil ass unit conversion on top of everything else. All right, so if we're talking about the inside, what we're looking for now is all of this. We have hints because we're talking about squares. And also because, well, we know if we're going to fill something, we're looking at area. So now we need to come back to our area idea. So give us a little more space. So I'm going to redraw my figure. I know my figure consists of two parts. The rectangle, and then it has two half circles on both sides, which is really just a whole circle when you put them back together, right? One half circle and then another half circle. So we have two figures that we need to find the area of. As usual, the rectangle is going to be easy. They told us that this is 64 by 100. So area of the rectangle is 6,400. Area of the circle, well, we already figured out for the last question that our radius was 32. Our area is going to be pi r squared. So let me figure out what that is. Pi 32 squared, squiggle button, 3217. I'm just going to round it because it was 0.99. So all I'm going to have to do is add these two back together. It also makes sense to us if you've ever seen a track field, right? There's a whole lot of area in the actual football field section, and then there's very little in the little circles at the ends. So I do think that this sort of makes sense. 6,400 plus 3217, 9,617 square meters. Anybody who actually took the time to try to convert that to square feet, you're my hero. I'm sorry. And then D says, what is the area of the track itself? So now we're saying, well, I want to know just this exterior part, right? This picture's getting cray-cray, but we're just looking for the track, right? If we were going to cover this with those weird rubbery thing or whatever, how many square feet of rubbery crap would we need? So the easiest way to do this, and I say easiest and it's not easy, is to take the area of the big thing, this whole thing, from edge to edge, and subtract off the area we just found. Because the area of the whole thing is exactly the same calculations we just did, right? So I'm going to do this again. The bigger one, it's still 100. Difference now is it's not 64, right? If we take 64 and we've added 10 on both sides, it's actually 100 by 84. So now the area of a rectangle is 8,400. And we already dealt with the circle. We saw that the circle, while it increased on both sides, the radius is only on one side of it, so it's now a 42. So we'd have a pi times 42 squared. Which is 5541.77. And if we add those together, the area of the big thing is going to be 13,941.77. And we're going to subtract off the inside area. To figure out that the area of the track is actually pretty substantial at 4,324.77 meters squared. Sorry, cat is all up in my business. So, like I said, those last two were challenging, especially D, but you can see on our previous test, D was marked with a double star for being extra credit.